Hello everyone, this is Direwolf20 and welcome to part 3 of my RFTools control mod spotlight. Today we're going to be looking at some advanced and more complex mechanics that you can do with these processors. Because they're basically computers behind the scenes, there's some complex stuff you can do with them that is a little bit more advanced than what my previous 2 episodes showed. So if you're looking to do something more complex and you've been struggling to understand some of the more complicated concepts like locks and several other things, we're going to be talking about them today. So today we'll be talking about locks, processor exclusivity, and a few things like that. So without further ado, let's get started. So one of the first things I want to tell you guys are locks. Locks are pretty useful little devices that you can use in your programs to prevent race conditions and prevent multiple things from happening at the same time when you don't want them to happen. I'm going to demonstrate this with a very simple redstone program. So I've got the following program here. We've got the program without locks has event redstone on. This thing is going to set the redstone on the north side to level 15, wait 5 seconds, set it to 0, and wait 1 second. Okay, that's without locks. That's what this no locks program has. So when we press the button, you'll see there, and we've got this debugging core thing up top. It waited 5 seconds, and now it's waiting 1 second. So that's all there is to this program, right? Simple, straightforward, effective, right? Now what happens if we run this program twice during the time that the first time it's running is still active, especially when we've got the event redstone control single set to false. If this were set to true, it would prevent multiple runs. But with single set to false, it allows multiple runs. And notice what's happening now. There's waits going on. And yeah, we didn't get 2 sets of signals. We got 1 set of signals, right? So there's the redstone being on. I can press the button again. You can see both cores are running. So core 0 is running the first time the program went through, and core 1 is running the second time the program went through. And they're kind of running in parallel with each other. And during that first 5 seconds, the redstone's already on. So it goes to turn it on again. And basically what we get is 1 running of the program instead of 2. What if I wanted this to run twice in succession, right? If I wanted it to run 5 seconds on, 1 second off, and then 5 seconds on, 1 second off again, we'll enter the locking mechanism. So first we're going to show it running, and then we'll explain how it works. What happens is when I run the program a second time, notice how core 1 just sits there as busy. And you can see the word locks saying 1. Now core 1 is allowed to run, and it's going to go ahead and kick off. Cool. So we get 1 iteration of 5 seconds on, 1 second off, and then a second iteration of 5 seconds on, 1 second off. So how does this work? It's really easy. All you have to do is add the locks. When you add a lock to a program, it's going to lock the processor and prevent it from running a second iteration of the same program. So locks are processor specific, meaning the block. So when one program in the processor calls a lock and it gives it a specific name, be it 1, be it dire, be it lock this code, whatever you want to name it is fine. If another program tries to run, be it the same program card or a different program card, and it tries to lock using the same name, that program will be told, hey, you can't run right now. There's already a program with this lock running, and that has to unlock itself before you're allowed. So what happens is this program that got locked just waits until the unlock command runs in the other program. Cool? And that's what the end here does, release lock. What that does, it says it unlocks it, right? So it's pretty straightforward if you think about it. Basically, the first time the program runs, it locks and it says, I'm locking with the name 1. The second time the program goes to run, it goes to lock with 1 and it says, hey, 1's already in use, that lock. Wait until I'm done. Okay, the unlock just occurred. Now you're allowed to run core 1. And core 1 kicks off and runs. And like I said, you could have multiple programs in here. Why is this especially useful? Well, imagine the crafting scenario we had earlier. Remember that it pulls some items into the temporary buffer here to craft. What if we ran into a scenario where 2 programs were trying to craft at the same time? One would try to pull items in, the other would try to pull items in, and they might conflict with each other, and either items would get blocked from getting pulled in, and some kind of weirdness would happen. So ideally what you would want to do in your crafting program is say, hey, lock down the processor with the word craft maybe, just name it craft to make it easy, right? And then pull your items in. Any other piece of code that tries to run to interact with those inventory slots, you would want to have a similar lock with the same name on it and say lock with craft. Then when that second program goes to run, it'll say, oh, there's already a lock there. So I'm not going to try to pull items in until the program that was first running is finished. So it's a way to kind of lock down the processor and prevent multiple operations from impacting each other at the same time. The next thing I'd like to talk about is another little button up top here called exclusive mode. If you mouse over it, it seems pretty straightforward, and it is. If pressed, then programs on card X, this one, can only run on core X, this one. So remember before when we were in an exclusive mode, first time we ran the program, it executed on core 0. Next time we ran the program, it executed on core 1 because that was the next core available. With exclusive mode enabled, it can only run on core 0 if it's in slot 0. So we'll see what happens now. Watch. Exclusive mode on. Now when I run the program, it's running on core 0. If I run the program again, notice how the event queue increases. Whenever you run multiple programs and there's no core to process them, they get added to the event queue. So notice core 1 was never used. Cool. And it ran in sequence. So again, we run the program. It's allowed to run now on core 0. It's not allowed to run on core 1. It's only allowed to run on core 0. And it gets added to the event queue, which eventually kicks off after the first program is done running. That has nothing to do with locks, by the way. This would be the same instance if we use the no locks program, right? So we just click this button, we click it again. So this is another way to make it iterate through the same sequence of steps. It kind of locks down which core is allowed to be used by which program. And as you might expect, if you go ahead and throw that program into core 1, so this is slot 1, now only core 1 can run the program. Core 0 is not allowed to run it. Cool? So again, a nifty way to make sure that only certain programs use certain processor cores. The next thing I want to talk to you guys about are tokens. Tokens are nifty little items. They're basically like mobile variables, and they're really neat. Let's go ahead and check them out. So you guys are familiar with a program like the following, where I can press a button and read what's in a chest, in this case stone, and write it out to the console. That's all this program does. It should be pretty straightforward for those of you who followed along with parts 1 and 2. Redstone event, examine item in the north inventory in slot 0, and write it to the console. How about instead of writing it to the console, we write it to a token? For that, all we need to do is bring over this thing and say, set value in token. And we have to give it the slot inside the internal inventory of where this token is going to live. Okay? So all we do is say slot 0. And then we're going to put the token in slot 0 and make sure the program can access slot 0. And then press the button. What that's done is written information to this token. It's basically like a variable that you can carry in your inventory. Why is this useful? Well, there's tons of reasons this could be useful. If you wanted to write down what's inside a chest and save it for later, drag it in later and read from it, if you wanted to transfer it from one processor to another, lots of different reasons you could use this. And basically what we could do from here is write a program that says, let's clear this, and say something like get value from token in slot 0, and write that to the console. Cool. When we come over here now, and I'm going to take this program card out, and I'm going to make sure a token is in slot 0, and press the button. Uh-oh. 3, 2, not a token. Oh, right. It needs to be in this program, slot 0. There we go. Minecraft : stone. So tokens basically allow you to write information, any kind of variable, to an item in the world instead of just to a memory slot over here. And then that item can be saved for later. Think of it like a USB stick or something like that. Let's go back to that no lock program that I wrote, which is simply when you receive a redstone signal on the south side, go ahead and activate a redstone signal on the north side for 5 seconds, then turn it off and wait 1 second. The reason I want to use this program is to demonstrate for you guys how to use the debugging console to figure out where problems might exist in your code. So as you write code and get more and more complex, it might become more of a challenge. And what else I'm going to do in here is probably, let's do this. Let's move this guy around a little bit. I want to add a little bit of code here. So let's do something like evaluate an integer. And we're going to say, we're going to have an integer value of 15. Cool. And that's going to get written to a variable. So set variable. And we'll say variable 0. And from there, we're going to set the redstone level equal to that variable level. right? So basically it's the same code, except we're using a variable to store the number 15 in variable 0. And then we're setting the redstone signal equal to variable 0. And then maybe over here, we'll kind of do the same thing. We will set variable 1. So we'll get redstone signal 0 is what we're going to want. And we're going to store that in variable 1. And you know what? Let's store it in variable 0. Cool. Just to make it a little bit easier to follow. And then your level will be set to variable 0. Good deal? So this should be the same code pretty much, assuming that I didn't derp something up. Let's see what happens. And we're going to take this program card out and put it away. Press the button, and you should see that variable 0 is showing a constant of 15. And then after that 5 seconds, variable 0 should be showing a constant of 0. Pretty simple. So how can we use the debugging console? Well, if we type help, we can see that there's a bunch of stuff we can do with db debug. With db debug mode enabled, okay, you can also debug it for an individual core, but for now we're going to debug it for all cores. When we execute code, it's only going to execute one step at a time. So let's see what happens. I press the button, and notice how it says db up here. Click button. Okay. db info will show us what we're currently on. So core 0 is on step 1, 2. What does that mean? It means if you look in your program here, 0, 1, 0, 1, 2. So 0, 1, 0, 1, 2, it's on this. And it's telling you even that it's an event redstone on. Cool. And it's just sitting there. Instead of going through each line of the code like it has been all series long, it's just stopped at 1. It says I'm on the redstone signal event, and I'm just going to sit here. If I db info again, it's still sitting on that redstone on. Cool. If we look at our memory, we're still at constant 0 because we haven't yet gotten to the step where we set variable 0 equal to 15. Now if I do a dbs, that stands for step, dbs. And I have to give it the core number, so it's core 0. Now we're at 2, 2, eval integer. And if I db info again, it'll show me again, we're still just sitting there, eval integer. That's all we're doing, okay? Eval integer, we're sitting at that. 0, 1, 2, 0, 1, 2. Cool. If we db step again, db step core 0, now we're at 3, 2, do set var. And we'll notice that we're still at constant 0. This is the step that we're currently on. We haven't executed it yet. Okay. If we db step 0 again, we're at step number 4, which is do redstone. At this point, we've set the constant variable, so we've executed this step, and our next step to execute is setting the redstone signal. Okay. So you can see here, redstone power has not been set yet. db step 0 again. Now, redstone signal is on, and we're waiting for the operation to execute. So we haven't gotten to this step yet. Well, we're at it, but we haven't executed it yet. That's the next one. So db step 0 again, and you get the gist, right? So now it's counting down its timer. Cool. And if we execute all the rest of these, we can hit db resume to just let the program finish as usual. So that's how we can use the debugging system inside the processor to figure out where problems in our code might be arising. So if you're running a complex series of code and you get stuck somewhere, try using the debugging method, and you can step through each individual process, each individual opcode, and see where things are going wrong. One more thing I want to show you is the debug last command. So if we do this, db step 0, and we get to the point where we are evaluating the integer that we just evaluated, remember over here when we set variable and we use the function last int to figure out what the last thing it was that exported? Well, if we come over here and do db last, it'll tell us what that is. Last integer is 15. So as you're stepping through your code, that might be useful to know. Want to draw fancy graphics? Let's see how. So if you scroll down to the green section, you should see there are 4 opcodes that are related to graphics. There's also one or two up here in somewhere. There's a graphics select event, which you can, which I'll show you guys in a minute. You can use, you can interact with graphics to actually execute code, which is pretty cool. Basically like a touchscreen monitor, if you will. But that requires RFTools controls screens, which we'll also show how to interact with in just a moment. It's really easy. But to get started, I'm going to make sure that my programmer here is set to graphics display. So instead of showing the DB debug like we've been showing, we're showing graphics. What this means is any programs running on the processor will show their graphics hovering over the console like we just saw a second ago. Okay, so let's look at the 3 opcodes that actually set graphics, and then we'll look at the 4th one that clears them. So first you have to give it an ID. This is just a name. This is what we name this specific graphic that we're drawing. So the first opcode we're going to look at is a graphics box. It draws a box. Seems pretty straightforward. And that gives an ID to identify the box. The location is 0, 0 for the top left. And I want to say it's something like 128 is the bottom right. So 128, 128. And we'll test this by throwing another thing over here. We'll name it Dire Graphics 4. We'll say the location can be, let's say, 100, 100. And we'll make it 28 by 28. Okay, so this is the location it starts at, and this is the size of the box. Finally, we get to color. Color is a little bit tricky. If you understand hexadecimal color codes, it's probably going to be your best. You want to start with a $sign to indicate to the program here that we're defining a hexadecimal color code. And then the 4 color codes are... You start off with the alpha, which is how transparent it is. The highest number in hexadecimal is FF. The lowest number is 00. So if it's 00, it's going to be completely transparent, and you won't see it at all. So don't use that unless you want it to be transparent for some reason, if you want it to be invisible. I don't know if you can draw a kit in invisible ink, but if you can, go for it. FF for the least transparent, which means completely opaque. And then you do red, green, blue. So if we want it to be a red box, it would be FF for the most red possible. And then 00 for green and 00 for blue. So this should be that color box. Now, that's going to change the number down here to a decimal number. That's fine. Okay, so we're going to save this program as graphics. Okay, the other one is line, which is pretty similar. I used a different ID for my line. I start at 1515 and I go to 2525. It just draws a line from that point to that point. And I chose a color to use. And then text, pretty similar. ID, location to start writing the text to write, and the color. Cool. So all those should be pretty apparent. And this is all running on a south side redstone signal. So let's pop this card in here and hit the button. Boom. Nice. Now, if you slow down the video, you should see that it rendered each of these in order, with the red one being the very last. On the right, I have a clear. It doesn't clear them all right now, but you notice the blue popped in first. The clears are all pretty easy. So let's load up the clear program. I'm going to add a clear to remove my graphics 4. So in doing the spotlight, I found a bug. And it's supposed to be an optional variable here. And you look at clear, it says if you want to delete all the graphics, you just leave it blank. So that's not working. But it'll work probably by the time you guys get to start playing with this. So McJady's aware and he's fixing it. So FYI, little bug there. But for now, I'm just clearing each individual graphic that I wrote. Okay, and that's on a north side of redstone signal. So clear. Cool. So the way this renders is it renders in alphabetical order of the names. So you would think that it runs in the opcode order. So graph this one, this one, this one, this one. It actually runs in the alphabetical order. So if I changed this ID to be AA graphics 4, and then saved this program, it should render the red square first. So I'm going to clear. Like a derp, I overwrote the graphics program with the graphics clear program, but this should help clear that up. This actually has to be south. So I'm just doing the top left square and the bottom right square now. Cool. So basically, they're in alphabetical order. They're not in opcode order. And that's going to help you if you want to overlay images on top of each other. Now, we can also output this to a screen, which I happen to have right here. Ta-da, we've got a screen. So to use this with a screen, it's really easy. Get yourself a vector art module and shift right click on the processor and install it in there. Neat. No longer do we have to have the vector art above the processor, we can have it on the screen. Cool. Note, by the way, that the screen top left corner includes the border of the screen. So that blue thing is up there. This is useful if you make your screen transparent. And if you don't like the way that looks, feel free to edit your build program here and make it start at location 1, 1. I think that moved over a single little pixel. It's pretty small. It might have to be like a larger number. There you go. I went with 10, 10. So it's probably somewhere around 5 or 6 is where that top left corner is going to be for you. Cool. So that's how you can interact with your screens with RFTools. And again, you can have it be transparent background, or you can have it be larger size transparent and largest size transparent. Pretty cool, right? So you remember my little demonstration program earlier that we used to do the timing of the redstone and everything? How about instead of doing it when we click a button on the side, we do it when we click this dude? Cool, that sounds good, right? So we'll leave this constant alone and we'll output this dude here and we'll say save. So I've named my program run on screen, and basically when I left click on a screen, it should output a redstone signal. Neat, how cool is that? So you can use that to interact with your computers. It'll also get, I think, the location of where you clicked on things. So let's modify this run on screen program and just change it up a little bit. So instead of doing this, I'm just gonna have you write to the console whatever information you get so we can find out what this guy does. Cool. So we save this, we insert it here, and then when we left click on the screen, we'll see that it writes out 6268. That's the location on the screen where we clicked. Neat, 31.3. Far left. All the way up there. Cool. Well, yeah, you get the gist. Cool, right? So you can find the location on the screen of where you clicked, and you can use that to do some kind of nifty touchscreen control if you want. You could have it so that you can draw buttons on a screen, and then you can make it so that when you left click on the screen, it does something with the program. The sky's the limit, right? So let's talk about exceptions. Exceptions are pretty cool. You can catch when a problem's going to occur and deal with it, and give yourself a nice little friendly message. Let's give an example, right? When I run this program, it's going to output that redstone signal. And as you recall, the program uses a variable. The variable in slot 0, which is currently set to 0 because it finished running, right? So every time this runs, you're going to look at that slot and you're going to say currently it's 15. When that timer's done running, it's going to go ahead and set it back to 0. Cool. Now, what if I forgot to assign a variable here, right? If I didn't do that, what kind of problem would we have? Let's find out. So if we don't assign a variable and we try to run the program, it doesn't run and it says error missing variable, right? Let's say I wanted to catch that exception. Simply install a program card that catches exceptions. And now when I click on the thing, it says, you forgot to assign a variable, Dyer. Derp. So how does this program work? It's really pretty easy. First, you do the event exception. This is going to catch an exception in your programming. And you can specify the exception right in here. So there's a lot of options that you can go through. Forgot a token, forgot a parameter, forgot a destination, graphics card, too many events, missing last value. There's tons of these things, right? Click, 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 right? So you can specify exactly, right? No RF, no liquid, whatever. And basically, the one that I chose for this instance, missing variable, right? That's the exception that we're catching. So that whenever we try to do something and we forgot to put a variable in there, it catches it and tells me in the console. Neat, right? So exceptions are pretty easy. Nothing too complicated about them. Very straightforward. And with that, guys, I think it's wrapping up point for the last and final part of the RFTools Control Spotlight. Clearly, I haven't covered every single opcode in here, but you should be able to, for the most part, figure out how everything works, given the information that you learn from these 3 videos, right? So, for example, I didn't cover test equality, but considering I showed you guys how test grader works, you should have a pretty good idea of how test equality works. You can also check test NBT equality. We didn't cover loops, but you should be able to figure those out. So pretty much everything that you guys learned so far in these 3 episodes should give you a very strong and solid foundation to proceed with learning the rest of the mod on your own. And that's the plan. So for now, Direwolf20 signing off. Hope you guys enjoyed RFTools Control. Super powerful, really cool mod. Really impressed with it, and I really expect that you guys who are interested in doing even just a little bit of programming learning. So listen, if you would like to learn programming and you're intimidated by things like computer craft, give this a try. It may not seem like it, but doing stuff like this will get your brain thinking like a programmer does, which is, I need to go and execute something. Let me break it down into individual little pieces called opcodes and figure out how I can piece what I have together, these opcodes, into a working program to get me where I want to be. I'm telling you, it may not seem like it, but if you want to learn to program, this is a great place to start. It will get your brain thinking like a programmer. Eventually, you'll get to the point where you'll start writing code, and what you learn here will help you a lot because you'll just, instead of dragging icons onto a board, you'll be writing code commands. And you'll be doing the same thing. You'll be breaking down a program into its individual steps and building them out to the point where you finally get a program that works. So play with RFTools Control, guys. It's a lot of fun, and it will definitely be enjoyable and let you do some really cool stuff in Minecraft that you can't do with a lot of other stuff. All right, guys, Direwolf20 signing off. Hope you enjoyed the series. For now, take it easy.